All right, hello everybody. From a new, very short episode, hopefully. A friend of mine have seen my bistable flip flop, and he said, "Well, why two LEDs flipping back and forward? What do you say to make another blinker, but with three LEDs?" He gave me the circuit diagram, but this is actually this is a diagram made by an Indian. An Indian made this exactly this circuit, but instead of one LED, the Indian used three LEDs per branch, so in total 9 LEDs. But it doesn't matter that, and it was made with through hole components, not with SMDs like I'm having here. So initially when I started this project, I wasn't thinking clearly. Probably I was thinking in different directions, and the only direction I was thinking, what I was concentrated, was to consume some old and weird transistors that I'm having. And here it is. This is the weird transistor that I'm having, one of many actually that are scrapped, and it's having this pin out is very weird. And you can see it here on the breadboard. These are the actual transistors scrapped that I tested there before starting anything. Then I made the layout here. Then I realized when I made the probe here, it didn't work. And then I realized I fucked up the pins. Here instead of base, I was having the emitter, and here the base. These two flipped these pins, because when I inserted there into my transistor tester, I'm inserting it with the face, with the flat face pointing up. And when I bring it here, I forget to mentally switch the pins when it is with the face up and with the pins in that direction inserted in that socket, that blue socket that you see there. Usually I'm doing this mentally, and I'm turning around the component, and then I'm putting the correct labels for the pins. But this time I don't know, I didn't think at all to make that conversion in my mind. And after some scratching in the head while I was testing here, I took out my Beche 548, because this circuit diagram it's from an Indian, and I said, well, maybe this is not good. And with the Beche 548 worked absolutely perfectly, and it worked. And that test with the 548 gave me the answer that this circuit diagram is actually good. I had to tweak it. You see these values here, specifically for this type of transistor here, and for my Beche 548 I had to tweak it also. Very hard to tweak these resistors, very hard. And because it was a trial and error until I get it as I wanted. And yeah, that's the story about this circuit here. I was with the cardboard in my hand, holding it in my hand, to actually starting to transfer this circuit to the cardboard, to the final cardboard board, like this one that is here. And then I realized, hopa, maybe my friend, he was thinking at that circuit to make it actually with SMDs, because that's the attraction, when it's made with SMDs, very small. So that's the story of this circuit. And then I switched gears pretty much. I took a break, and then I switched gears. I concentrated only on SMDs after that. And then I started this layout to figure out. This is a sketch here, just to figure out how to place the components. As you can probably see, here is the transistor, that's a resistor, and in between this is the capacitor here. Very extremely important design element, and mostly neglected, is spacing, to leave room for your solder, for your tip of your solder to reach on the component pad, and to have space around to be able to solder it. And I know this problem. I know it from my experience, and I didn't make any kind of mistakes here. That's why this pad is looking very long here, to accommodate the way I'm soldering these components from here, then from this side here, and then from here. So I have room and space, enough space to actually enter with my tip of the solder and solder those motherfuckers. Also, these transistors, as you can see, the transistors are not straight as I originally designed. I inclined them a tiny little bit, so instead of straight, I inclined them like that. And why? Because for the legs of the transistor to actually catch well enough on these pads here and here. Here it was 2 on the margin, also this one, and probably this one as well. So way 2 on the margin. So I had to, and these pads that I'm making are not perfect. One of them was way too, the distance between them was a bit too great, and I had to incline that, and then I inclined the others after that. So it's looking like a okay pattern right now, and that's it. Is exactly this circuit. There's nothing wrong with it. Only these values are not the correct ones. Let me actually correct them. Okay, so for these resistors here, I used 1 kilo, 1 kilo, 1 kilo. And for the base of the transistor is 10 kilo, 10 kilo, 10 kilo. And all the capacitors, this, and this, actually I can show you here as well, this, and this brown ones. are 100 microfarads. Yes, that small is 100 microfarads. And all the transistors are 2M3904 with the marking on them 1 IM, and they are all NPNs. Here it is. This is the guy. 40 volts, 200 milliamps NPN. This is how the pinout. This is the actual marking on the case, and it's powered from 5 volts. One lesson that I learned from all this circuit is if you are using fucked up scrapped transistors from God knows where, like these guys that I had there, you have to tweak the resistor, and tweaking these resistors here is actually influencing the entire circuit in the same time, the speed and the luminosity of the LED. And especially if you are using scrapped LEDs and very old style of scrapped LEDs. If they are newer technology of LEDs, even if they are scrapped, they are okay. But those old ones are a pain in the butt. So you have to tweak the resistors quite a lot to get a good effect. I didn't tweak it here. I was expecting to tweak something here, but well, it's good enough. Even if it's like ta 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 ta, and it's kind of stopping a little bit. Probably more on the red. A little bit, yeah, and less on the yellow and blue. But this is tricolor. This is our flag, Romanian flag colors: red, yellow, and blue. Roșu, galben și albastru. I am ultra nationalist, using my flag colors, my patriotic flag colors. So yes, and vice versa, the opposite. Another lesson about this circuit: if I'm using brand new components, all the capacitors that I used here are brand new; they are not scrapped. All the transistors are brand new, never used. Only the resistors, a couple of them, but maybe three or four resistors from all the 6. Probably they are used in other circuits, and but they are not that overused. And also the LEDs are very brand new. Also, the important thing is the transistors to be brand new to get a very quick and painless effect, and straight direct effect that I'm having here. So yeah, you can see it. I did. If you see my finger here, do you see my finger? That labeling 5 volts positive and negative, it's very tiny, the labeling, and I had to do it manually, and it was a pain to actually to write it properly, not to make mistakes. That was hard. Let me hold it in my hands like this to see how big or how small it is. It's like half of my finger here, yeah, like that. You see, pretty cute. My friend said, yeah, do it because it will look very cool. I don't know how cool it is. It's cool because it's made with SMDs, and all the components are condensed together here on this board, and you can barely understand what the fuck is going on there. But yeah, overall I think it's a cute circuit. For the cuteness of the circuit, I build it. This is again another toy, and I was thinking about this circuit. Actually, this is a counter, but this type of counter that is using capacitors, is a special type of counter that is not commanded from external pulse from somewhere. It will be a very interesting project idea to convert all this circuit that I'm having here to be able to from a single pin somewhere. You know, exactly like a counter chip, like a 4017 chip, like this bad one that I'm having here. This is bad, but the idea is exactly the same. If I can clock instead of these capacitors, or to bypass this capacitor somehow, to influence them through a single pin clock or something that can make a different speed, slower or faster, and that will be a very interesting project. So this is a special type of counter because this is an independent oscillator, independent because of the capacitors. If I would have clocked all this circuit from an external clock, it was dependent by that clock externally from external. This is the difference between these two systems. This is an internal clocking, an internal oscillating circuit, and the 4017 type of circuits or counters are externally clocked. So that's the difference between these two. But basically they are doing exactly the same thing. They are counting one by one. And this circuit, as you can see it here, it can be extended. If you can see here, this is a block of components. You see this 10 kilo, that 1 kilo, this capacitor, the LED, and the transistor. This entire thing is a single block, and you can move this block and copy it multiple times, how many times you want, and you will obtain a way longer circuit, and way more counting LEDs, pretty much, or outputs. Actually, it will not work with more than 3 LEDs. It will not count sequentially one after one. It will get into error mode. As you can see here on the top, is going weirdly, while here in this bottom side it is working fine. It's counting to 3, quite okay. But I tried with 4, I tried with 5, and this is the last trying with 6. modules, and they all get screwed up. Basically is doing 2 by 2, and is not good. I didn't know this detail about this particular circuit. Well, I was kind of having an idea, a very vague idea, that more transistors maybe will trigger in the same time, but I was counting on the capacitors to charge one after another, pretty much. That's I believe this is a driving element in this 3 modules element that I'm having here. All right. So that's an interesting observation that I was thinking. It will be interesting to get close to a 4017 counter from an external clock pulse. That will be interesting, and also maintaining this kind of simplicity that I'm having here. It's just an idea. It's just a toy. What I have here is I just played around, and I'm happy that it's blinking. I'm very happy that it's blinking in my patriotic flag colors. Right, another test I want to show you. I hope I can do it with one hand. Is this? Check this out. I'm highly recommending this test to do yourself in your circuits as well as I'm doing it here. Do it like this with a iron or metallic knife, like I'm holding it here. Do this. Whatever. This. You see? I'm shorting. What I'm shorting? I'm shorting this element here. This is a pad, actually. Is this pad here with that? So this with the base. Instead, the current to surge through the 10 kilo and opening the base of the transistor, the current is going through 10 kilo directly on the ground. So this way, the transistor is closing, is staying close, and the current is surging through this 1 kilo, and then is making a sharp 90 degrees turn and is going through the LED and is keeping the LED open. That's what is happening when I'm shortening these 2 pins. And the same here. If I'm shortening that base of the transistor and this negative rail like that, it will hold the LED open, and the same here as well. This is the way I was testing if the LED is properly soldered there, if I solder it correctly. So I'm shortening these 2 pads, and also for the blue LED here, yeah, like that. Yeah, see. So I'm highly advising you to stick your metallic knife somewhere into a circuit and short something. It doesn't matter what, like that. So you see, it's perfectly fine, and nothing is burning or anything because I'm doing it with my head, not with my dick. Okay, so this was the testing I was doing to see if the LED was properly soldered when I was soldering it, to see if the current is actually flowing through that 1 kilo. That is a proper connection between this and this, from this point to that point, pretty much. I was bypassing the transistor, doing it like this, and I'm activating this module. This is actually a NOT gate, what I'm having here. When it's receiving negative on the input here, it's creating a positive output here. And when it's receiving a positive here, is keeping on negative, or is closing this LED that is having that. So this entire module is actually a NOT gate. All right, that's it. Thank you very much. All right, that's it for this part. Thank you very much for watching. I hope you like my little project here, and see you next time. Bye bye from your favorite artist electronist, Mr. Q12. Ho, 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 ho.